Expansion of an ideal gas. How can you calculate the temperature of an ideal gas? The properties of an ideal gas are related by the ideal gas law, which states that the product of pressure, P, and volume, V, is equal to the product of the amount of gas in moles, N, the ideal gas constant, R, and the absolute temperature, T. In this isothermal expansion, you know that there are 5 moles of gas in the cylinder at an initial pressure of 1,411 kilopascals in a volume of 0.0200 cubic meters. This means that the only unknown is the temperature, since the gas constant is known to have a value of 8.31 joules over kelvins times moles. You can solve for the initial temperature, T sub 1, by dividing both sides of the equation by N times R. Hint: convert pressure from kilopascals to pascals so the units work out correctly. 1,411 kilopascals is equivalent to 1.411 times 10 to the 6th pascals. Substituting this pressure along with the other known values, you can calculate an initial temperature of 679 kelvins. A change in the properties of this gas can be represented on a pressure-volume graph. As the gas expands from the original volume and pressure at point number 1, the pressure decreases to the value represented by point number 2. If the volume of the gas in this problem increased to 0.05 cubic meters, you would observe that the pressure decreased to a final value of 564 kilopascals, which converts to 5.64 times 10 to the 5th pascals. Hint: the number of moles of gas remains constant since the gas is enclosed. The final temperature will depend on the amount of energy that is transferred into or out of the system in the form of work and heat. However, you can still calculate the final temperature, T sub 2, since you know the final volume, final pressure, and amount of gas. Substituting the new pressure and volume, along with the other known values, you can calculate that the final temperature is 679 kelvins, which was also the initial temperature. The observation that the two temperatures are the same makes sense, because the word isothermal was used in the problem statement to describe this expansion.